Hello guys, this is Arv here and I'm back with my new topic on physics. A new physics topic. Today we're going to touch momentum. You've heard about this concept a lot. But do you actually know what it means? Momentum. So what is momentum? Wikipedia gives me the definition that momentum is the quantity of a motion of an object. Now, what is this quantity? This quantity is the force or the strength gained by a moving object. And the momentum depends upon two things. The momentum depends upon the mass and the velocity. Okay, let me give you a situation like an example. Suppose I'm running a 100 meters race and assuming my mass is 50 kgs. And at the beginning of the race, I was running at 6 meters per second, and at the end of the race, assuming my mass remains the same, and at the end of the race I'm running at 3.0 meters per second, my momentum at 6 meters per second, because my mass is the same but velocity changes, the higher velocity with the same mass has a higher momentum. And so the momentum at 6 meters per second velocity is higher than the momentum at 3 meters per second velocity. Why? Okay, so how do you define momentum in a formula way? We can say that momentum, which is defined as P is momentum, is equal to mass times velocity. So, like I give you the example, if I'm running a 100 meters race, and I have to calculate my momentum at the beginning and the end of the race. Assuming mass is same, mass is equal to 50 kgs, initial velocity is equal to 3.0 meters per second, and final velocity 6.0 meters per second. I want to figure out if my momentum at 3.0 meters per second is more or my momentum at 6.0 meters per second more. So let's do for 3.0 first. So P is equal to mv. So P is equal to 50 kgs times 3.0 meters per second, which gives me 150 kg meters per second at 3 meters per second speed. Now let me calculate it at 6 meters per second. So P is equal to 50 kgs times 6 meters per second, which gives me 300 kg meters per second, which is surely more than 150 kg meters per second, yeah? When I say motion, I don't mean loose motion, okay? I mean the motion of an object, okay? Just mind that. Okay, just kidding. Alright, so the thing is, if 300 meters per second, kg meters per second is more than 150, and thus that proves that if you have the same mass, then the higher velocity produces a higher momentum. Alright? That's the basic logic. Now, I want to show you one great thing of how someone derived the formula of momentum. How do you derive that formula? How did you get this formula? You get this formula from the basic formula of modern physics, which is F is equal to ma. This is it. Alright, so I will show you the derivation of how to get momentum through F is equal to ma. Alright? Okay, let's go. Let's start. So let's start with the derivation. So F is equal to ma. So F is equal to mass times acceleration is basically velocity divided by time, right? Velocity divided by time. So mv over t. So force times time is equal to mv, right? So force times time is equal to mv. What is mv? mv basically goes back to momentum. It goes back to momentum. But we still haven't reached the end. What is force times time? What is force? Mass times acceleration times time is equal to p. What is acceleration? Velocity divided by time. So mv over t, because acceleration is velocity divided by times time is equal to p. T and t get cut. P is equal to p. Momentum is equal to momentum. And that is how you figure out the momentum formula from the F is equal to ma formula. This is how they derived it. This is actually a pretty good derivation. It's a pretty easy one, but it's actually a pretty logical and technical one. This is actually pretty cool. Whoever did this, they're a genius, including me. Yeah, including me. Just kidding, okay? Okay, so now you got the idea of basic momentum. I want to include one more concept in this. And it's not a concept, it's another derivation. I can derive the formula for momentum using F is equal to ma and the work, that's F d cos theta. The formula for work. If you don't know the formula for work, I recommend you watch a few videos to understand what work is. But for whoever knows what work is, you can use this formula to derive momentum. And I'll show you how. So for whoever don't know what work is, the work is basically the force times the displacement times the angle between the force and the displacement. Okay, now let's begin. How do you derive this equation? How do you derive the P is equal to mv? P is equal to mv. That's what we're trying to derive. Okay, so we know F is equal to ma and W is equal to F d cos theta. So what is F? What is F? F is equal to W divided by d cos theta. So F is equal to W divided by d cos theta. Now F and F is equal to each other, so we can set these two equations equal to each other. Because we know F is equal to W by d cos theta and F is also equal to ma. So we can say ma is equal to W divided by d cos theta. Alright? So what we can say now is we can bring this down to mv over t, because we know acceleration is velocity divided by time. So mass times velocity divided by time is equal to W by d cos theta. Hope you guys noticed one more thing. One more thing is, what is this? mv. mv is basically momentum. So p by t, that's momentum, is equal to W by d cos theta. You get it? Alright, so P is equal to time times W divided by d cos theta. I also want to make one more thing sure with you, okay? The units for P are this is mass, that's kg, and velocity meters per second. And when you find the units for P, we know that T is in seconds. W, work is newtons times meters. Work is newtons times the unit for newtons is the unit for work is newtons times meters. And d cos theta, d has a displacement of m, and cos theta is 0. There's no unit for cos theta. So when you divide m divided by m, we get ns as a newtons as the symbol for p. Let me tell you one thing. There is a difference between this and this, and I will show you the difference between them in the next video. The next video is going to be on impulse, and impulse is basically, if I have to define impulse, it's the large force acting on a very short time. Okay, it's the large amount of force acting on an object in a very short period of time. You could say the force acting when a tennis ball hits a racket. When it just hits the racket, it's a millisecond. It's a millisecond. But there's a lot of force at that point in time. So that's impulse. That's the idea of impulse. I will be introducing the concept next video. But for now, this is the idea of momentum and how you derive the formula. These derivations can help you find answers to your problems. You know, if someone just gives you the mass times acceleration and the work and d cos theta, how do you find the momentum? You find the momentum by doing this. And that's a derivation. A derivation is basically reading from one formula to another. And so this is one way of solving it. And I will introduce this impulse topic next video, which will be in the next 1 or 2 days. So then just grasp on the idea of momentum, review it more, take a look at it more, go into depth, and you get better at this. This is not a very hard topic. It's pretty basic. And I also wanted to talk to you about how momentum can change. Momentum can change in different things. Like I told you, it's dependent upon mass and velocity. Let's take a rocket, for example. When a rocket is launched, it keeps running out of fuel, and thus the mass keeps decreasing. And you also see the velocity changing. Now, that's the change in momentum. There is a constant change in momentum because you're losing mass and the velocity is changing. And that's an example of changing momentum. Changing momentum requires intense math. Specifically, I think to do with calculus and stuff ahead of calculus, maybe linear algebra and stuff. So for now we're gonna focus on the mass staying the same, but you can change the velocity. Because delta P is basically mv2 minus mv1, where mass remains the same. We're keeping mass constant in this case. So only the velocity changes, and basically you can do easy problems on that. So it's the basics. Later in the future, if you want to pursue physics as a career, or you want to pursue something to do with astronomy or astrophysics, you're required to learn intense math and solve those problems. So I think it's fun as long as you like it. Alright, so this is the end of the day. And this is over. This video is over. Alright, like my video, subscribe, like, share, comment, whatever you want, but just do something and help me spread knowledge.